Welcome, class. Today we are having physics, and the topic of discussion is projectile. Now, what is projectile? Projectile is an object that passes through a trajectory path. Now, look at this. If I should send an object into the air, it must come down. There's no object you send into the air that will not come down. So, because of that, what causes this is because of what? The acceleration due to gravity. Earth's pull must bring that object down. As it's going up, it will come down on its own. So, objects that we throw into the air, it could be a stone, it could be tennis, it could be football. You see a player, the player is with the ball and he plays it with his leg, send it to another player. As he sends it to another player, let's say he's here, this is the player, and he sends it to another player. There are obstacles around this region. Or let us say he wants to take a free kick and he takes the ball here. There should be an angle theta. This is angle to the horizontal. He would, on his own, in his mind's mind, calculate the maximum height of the players and how much they can jump. So as he takes it this way, the ball is to land at this point. From here, when he kicks the ball to this other point, is known as the what? The range. The range. This is the trajectory path the object will follow. And this point is called the maximum height. The maximum height of projection. The time to travel from here to the maximum height is called the small t, which is what? Time to reach maximum height. But from here to here, the time it covers is called what? The big T, which is what? The time of flight. Time of flight. Therefore, from this, we can all agree that the time to move from here to here and move from here to here is what? The same. Therefore, this is equal to 2 times of the time to reach maximum height. Now, what is the formula for time to reach maximum height? Time to reach maximum height, T, equals to U sine theta over G. Then time of flight, the capital T, time of flight, is equal to 2U sine theta over G. The maximum height, H, denoted by H, the maximum height is calculated with U square sine square theta all over 2G. Then the horizontal range from here to here is denoted by R. R equal to U square sine 2 theta over G. These are the formulas to use in solving questions. Okay, now we have a quick example I want us to look at, and that example is if a stone is projected at 30 degrees to the horizontal, 30 degrees to the horizontal, find the time of flight, maximum range, and the maximum height. Okay, maximum height. So let's use horizontal range. Horizontal range and the maximum height of the projection. If initial velocity is 20 meters per second. So with this example, we're going to explain in details all that. So we're going to have a short break now, and after the break, we'll continue with the class. Welcome back to the class. Now, we are to solve this question. The first thing you do in physics is to get your given parameters. With those given parameters, you'll be able to know the formula to use in solving. So here, in this question, we have our angle to be what? 30 degrees. And the theta is 30 degrees. And the initial velocity is u equal to what? 20 meters per second. So the first thing we have to solve for is your time of flight. So I is my time of flight. Time of flight is equal to 2u sine theta over g. This is equal to what? Acceleration due to gravity in our calculation. Acceleration due to gravity is taken to be 10 meters per second square, an approximate value. So in calculation, we are using this. You see 2 times what? 2 times 20 times sine 30 degrees all over 10. 0 cancel 0 equal to 2 times 2 is what? 4 times sine 30. Sine 30 is 0.5. So we have 4 times 0.5 equal to what? 2. And that is what? 2 seconds. 2 seconds. 2 seconds. We have to solve for the horizontal range. So the horizontal range equal to u square sine 2 theta all over g. U square sine 2 theta all over g. So we have this to be what? U. What is our u? Our u is 20. So 20 square sine 2 times what? 30 over g is 10. So we have 400 times sine what? 60 all over 10. 0 cancel 0. This is 40 times 0.866. That is sine 60 is 0.866. So I can manipulate this with my calculations. Now I have equal to what? 0 is here, so you have 0.866. Because of this 0, we are moving by one place. So we have 1 times 4. We are not using 40 again. So that is 8.66 times 4. That is equal to, this is 6, 4 over my 2. That is 34.64 meters. It's covering 34.64 meters. Now you can see in the calculation I did not use calculator. So I'm going to show you how to do that in the classes where we are going to be having multiplication. I'll show you how to do this kind of multiplication in our math class. So you stay tuned for that. Now, horizontal range, we have solved for horizontal. The next one is maximum height. Maximum height. So for maximum height, we have u square sine square theta over 2g. And that is what? What's the maximum? U there is what? U is 20. 20 square times sine 30 all square over 2 times 10. And this is equal to 400 times 0.5 all square over 20. Here 1, here what? 20. This is what? 20 times 0.25. That is give you what? 20 times 0.25. That's the quarter of this is 5. You know? That is 5 meters. The maximum height is 5 meters. So I can express this in my diagram that The maximum height here is what? 5 meters. The range covered here is what? 34.64 meters. Initial velocity theta equals to what? 30 degrees, and initial velocity is what? 20 meters per second. 20 meters per second, where G equals to 10 meters per second square. See, you are able to do justice to this. So thank you for watching. We're going to be having the continuation of this class for horizontal projections. We're going to expect that in our next class. Thank you very much. Please click the like button, share and subscribe. God bless you as you do that.